Rn. Now we'll try to determine Norton current. So to determine Norton current, we have to place a shorter between the terminals AB. You see, between the terminals AB, this is the AB terminal, so we have placed a shorter in the place of AB. So to determine current, Norton current, we need to place a shorter between terminals A and B. Then we need to determine the current through AB terminal. Okay, now let's see here. This shorter is parallel with the 5 ohm resistor. That's why we have seen that here the current through 8 ohm resistor is passing through this shorter without passing through the 5 ohm resistor. That means here 5 ohm resistor, it is acting as the open, because no current can pass through this resistor since it is parallel by the shorter. That's why the current through 8 ohm is equal to the current here AB terminal, that is IN. That's why you have removed the 5 ohm in the next circuit. It is one next circuit. You see the difference between this and this. We have removed the 5 ohm resistor because this is the shorter, is parallel with the 5 ohm resistor. That's why ultimately we are getting a short path between AB. Here we are saying that this is the small terminal A and it is the small terminal B. So we see here 5 ohm resistor is out at this network because it is the shorter. We have placed with the parallel of 5 ohm resistor. So no current through the 5 ohm resistor. That means it is out of use. It is not needed for us. So ultimately we are getting this circuit from this to this. So now our target is to determine this IN, Norton current. So let's see now. We are using, so to solve this problem, we are taking the mesh current here I1 loop current and here another loop current I2. And you see here I1 we can say here 2 ampere because it is the source current given. So since we are considering in this loop I1 is flowing, that means here I1 is 2 ampere. And in this loop we are taking consideration I2, that means I2 equals to here IN. That's why we have written I1 equals to 2 ampere and I2 equals to IN. Now if we apply Kirchhoff's voltage law at this loop, it is A, B, C, D, then we see that here if we apply Kirchhoff's voltage law at this second loop A, B, C, D, we see from this network, if we start from A, that is where through 8 ohm resistor the voltage is where across the 8 ohm, current is IN multiply 8. That means we can say here it is the plus 8 IN because current is considering in this clockwise. That's why it is the plus 8 IN. Then if you consider here plus 8 IN, you see we have written here plus 8 IN plus 8 IN. Now say if you go this way, that means here first sign is minus, so minus 12. You see here we have written minus 12. Then we see here, so since we are considering this loop, so 4 multiply here I2 means IN minus I1 means 2. That's why we are writing 4 multiply IN minus 2 ampere. So that is our format, 4 multiply IN minus 2. So you see, there is no other equipments, there is no other components in this ABCD. So ultimately we are taking here equals to 0. So if you calculate this, we are saying that here 8n plus 8n 16 in minus 12 plus 4 in minus 8 equals to 0. So after calculation you are getting here in equals to 1 ampere. So we have determined both in and Rn. So we can draw the simplified network, that is Norton equivalent circuit. In parallel with Rn. In value is 1 ampere, Rn value is 4 ohm. Okay, now we are trying another math, practice problem 4.11. Here we see that this is the network. So we need to solve this network to find out the Norton equivalent circuit. So as usual, as we have seen, first we are going for to determine Norton resistance Rn. So to determine Norton resistance, we know we need to remove all source. So voltage source by the short circuit path and current source by the open circuit path. It is same for the all maths. So if you now consider from A to B, the resistance would be known as Rn. So if you consider from A to B, you see this current is divided this and this, that means 6 ohm is parallel with this part. This part means you see 3 ohm resistor current is also passing through this 3 ohm resistor, that means 3 ohm series. So this total part is parallel with the 6 ohm resistor. That's why we have written here Rn equals to 6 parallel 3 plus 3 equals to 3 ohm. So we have determined Rn. Now we are going to determine In. So let's see here, to determine In we need to place a shorter between terminals A and B. Then we need to determine the current through that shorter terminal AB. So this is our network. Now you see this shorter is parallel with the 6 ohm resistor, that means 6 ohm resistor across current is 0. That's why you have removed the 6 ohm resistor. Now after removal of 6 ohm resistor, we are getting this figure number C. We have removed the 6 ohm resistor here. Now we'll determine the current In. So to determine the current this In, we are going for simplification of this network by the source conversion. We know how to convert the voltage source to current source. It is the voltage source 15 volt. Now we are going to convert it to the current source. This is the current source. Current source I equals to V by R. Here B is the 15 volt. We have seen here B is the 15 volt divided by resistance 3 ohm. So ultimately we are getting voltage 15 divided by 3 ohm resistance equals to 5 ampere. So this is our current source I. Now it is parallel with the resistance 3. So you see current source, this 5 ampere is parallel with 3 ohm resistor. Okay, then you see the rest remaining part is unchanged. So it is the figure D. Now we are going for further simplification. You see here current source 4 ampere and 5 ampere is in same direction, upward direction, 4 ampere and 5 ampere. So since they are in same direction, it should be additive. That means 5 ampere plus 4 ampere 9 ampere. Then in parallel 3 ohm resistor. So this network is this simplified form. So is the 3 ohm resistance. Now we are going to determine In. So we know how to determine In using current divider rule. This is the total current 9 ampere multiply, you see this is the In through 3 ohm. This opposite resistance we need to consider. This is the 3 ohm. So we have here written 3 ohm divided by total resistance 3 plus 3. It is the 3 plus 3. So after calculation you are getting 4.5 ampere. Now we are drawing the Norton equivalent circuit. IN parallel with RN. IN value we have got 4.5 ampere and RN value we have got 3 ohm. So this is our Norton equivalent circuit. That is our answer. Our next topic will be maximum power transfer theorem. So thank you everybody. Please try to follow this lecture and you may take the help from the book. Thank you everybody.